Guys, here's another video on a Desmos thing. So this one is for inverse normal distribution on Desmos. So this goes with lesson 3 of our normal distribution chapter. So again, the video lesson in Canvas today went through, when I went through this PowerPoint, I showed how to do inverse normal on a graphing calculator. But I'm going to show you guys how you can do that on Desmos as well. So we're going to go back to Desmos. So again, just go to desmos.com, click on Graphing Calculator, and we're going to start the same way we did with normal distribution. Go into this little keypad down here, click on Functions, click on Distributions, and today we are using inverse distribution. The lettering that you see here obviously is the word inverse. And then you see the little CDF, that is for cumulative distribution function, which is what we're doing. So, so the way that you put this in is a little bit weird. When we say we're going to do an inverse cumulative distribution function, well, you can do inverse functions of many different things. So we have to first tell this thing what we want to take the inverse of. And so we want an inverse normal distribution function. So within these parentheses, the first thing I have to type in is go back into my menu here where it says distribution and click on normal distribution. So this is going to be an inverse normal function. Just like in lesson 2, within these parentheses, we're going to put the mean and the standard deviation, just like we did in the last lesson. So if I go back to my PowerPoint slide, so here's the one we're going to look at. This came up in today's video lesson. This one I went through. So it says the mean is 995, standard deviation is 5. So in here, my mean was 995, that always goes first, and then comma, and then your standard deviation, which was 5, and then close your parentheses. So this interior piece is exactly like what we did in the last lesson for normal distribution, right? The mean goes first, the standard deviation goes second. Here's the extra piece, is we now need to tell this calculator what percent we're dealing with. So if you go back to our example here, so remember, inverse normal takes place when they give you a percent and you are being asked to find a specific x value that you see on the x-axis down here. Okay, so with like this problem said, it is known that 10% of the cartons are less than x. So if we had the curve in here, and I don't know why it didn't come up in this, but there's supposed to be a curve in here. Let me see if it showed up. No, that's the next one. Anyway, if we looked at the curve in this, if we said that there is 10% less than x, that means x would be some number over here because there's only 10% shaded below x because it says 10% less than x. So x would be somewhere, some number over here, probably close to 980. I don't know because there's no graph up here. But it's going to be some x-axis value over here. We need to figure out what that is. So the key on inverse normal is recognizing that when we put in a percent, this calculator always wants to know the percent that is to the left of x. Now this problem in particular already told us that. This one already says 10% less than x, which is what we want. I'll show you the difference in a minute. So if we said 10% less than x, here's all we have to do, is right after that parentheses, we have to first put a comma, and then we are going to put the percent left of x. So in this case it was 10%, so I'm going to put 0.1, and voila, it tells us our answer. So if we had the curve on here, it didn't draw it because we're doing the inverse of a different function, but with this one, if we had the curve drawn, so the area below 988.6 would be 10% of the curve that would be shaded. So this tells us our x-axis value that we were looking for. I told you guys the key on this was recognizing that we always want the percent left of x. So what if they give you the percent more than x? So if they were to say something like, and I think I had one on the previous slide, let me look at this one. So they're talking about this one here where they said, what if they referred to the top 5%, right? So in other words, if they give you some information that references 5% to the right of x, well, if there's 5% to the right, how much is to the left? Because remember, this has to total 100%. So if there's 5% to the right, that means there's 95% to the left. Right? They both refer to the same x value. There's just two different ways of describing it. So I can either tell you that there's 5% above x, or I could tell you that there's 95% below x. I would still be referring to the same x. Right? That x is not changing positions. It's just a different way of describing it. Right? Whether I tell you the number to the right or the number to the left. But like I said, the key is we always put in the number to the left of x. So if they ever give you something to the right of x, subtract it from 100% so that you can figure out what is to the left. Let me go over one more with you if you need some extra practice. Let me get a little later on this. Okay, so here was a normal distribution. Let me go back to inverse normal. So if you look at B, it says it is known that 8% weigh more than m. So m is our variable. So if 8% weighs more than m, how much weighs less than m? Because if we talk about 8% above m or to the right of m, that's not what needs to go into our calculator, right? So if there's 8% to the right, that means there is 92% to the left. Okay, and that's the percent that we're going to need. So let's put this in just for extra practice here. So my mean is 110 and my standard deviation is 8. So let me go back to this guy. So my mean is 110 and my standard deviation is 8. And so after those parentheses, remember there's a comma first, and then now we need to put in the percent left of x. So they said that there was, let me make sure I'm getting the right numbers on this. So they said there was 8% more than m, which must mean that there is 92% below m. So I put in 0.92 to represent 92%, and right here is my answer, 121. So same answer that we got from the PowerPoint stuff. There's the 121. Again, I just showed in the video earlier how we could do it with a graphing calculator, so I just want you guys to know how to do this stuff in Desmos. So again, I hope that helps. That's it for this one.